Basically said like this is on the state, and this is like last thing you got.
So Evan, that's here. Someone Coach said we couldn't do it. Sorry.
You can't go another one of those. We'll say for God. All right, so this is what this has all been about, what we've been waiting for our whole lives.
I just have it.
You have been waiting for this your whole life. You just didn't know it. Now what we're going to do is we're going to take all this stuff that we learned and we're going to use it to solve exponential equations. So these were ones where before we were kind of guessing. Remember when we did the modeling problems and we were trying to say, when is the population going to be this certain number? And we just kept putting in different values for x until we got close to that. Now we're going to do this exactly using our new algebra skills, okay? All right, so if I want to solve this for x, your math instinct says, what do I do first? Isolate the variable. Nicely said. Okay, what would be your first step towards isolating the variable? Whisper, whisper, mumble, mumble. Divide both sides by 20.
Why are you doing that?
Because you have 20 times some stuff.
Okay.
So you do the opposite,
Okay.
which is divide by 20. And then that gets rid of that, okay? So yeah, first step, divide both sides by 20. Now we have the issue that we had before, where we have a variable in the exponent. We have never known how to deal with that until now. What can I do to get the variable out of the exponent? Log both sides. So I'm going to log over here, and I'm going to log over there.
Great.
I am. In what way? What? Okay. What is the property that I can use now to get that exponent out of the variable out of the exponent? No, I locked both sides already, so I've done that thing already. Yeah, what can you do with power? When you have a logarithmic function?
You can move the exponent to the other side.
Good, I can move the exponent to the other side, so I can take this and put it down in front and rewrite this as x over 3 times the log of 1/2 equals the log of 1/4. Now I have got myself out of that problem that I was having. So now solving for x is easy. Two-stepper. What do you want to do first? You want to get rid of the 3 or you want to get rid of the log 1/2? You want to get rid of the log 1/2? Okay, what is the log 1/2 doing to the x? Multiplying. So to get rid of that, I'm going to do the opposite. So I'm going to divide both sides by the log of 1/2. Okay? So these cancel. So that leaves me x over 3 equals the log of 1/4 divided by the log of 1/2. What do I do to get rid of the 3? The 3 is dividing, so I need to multiply both sides by 3. So I multiply over here by 3, and I multiply over here by 3. So those cancel. And now you can just type this whole thing into your calculator basically the way it's written right now. Log parentheses 1/4 or 0.25 if you want, divided by log of 0.5, and then take that answer and multiply it by 3, and you get 6. That's the answer. To get rid of the 3 at the bottom.
And then,
Right, x equals all this junk here, yeah, which I just didn't want to rewrite because a lot of it, it's a lot of writing. Okay?
No.
So the awesome thing about the logs is that deal where you can change this, like Becca said, that's the whole magic. You take that exponent and put it in front and make it multiplication, and then that allows you to do simple operations to undo the equation and isolate the variable.
I got 8.
You got what?
8.
Did you close your parentheses after the 1/4 and the 1/2?
Yes. Okay, I don't know.
Okay, I can look, well, you're helping. All right, let's take a look at another one. A little different form. This doesn't have a variable in the exponent, but it is wrapped up in a log. And so we have to do like Becca said, and what did you say? Isolate the variable? Okay, so I need to get rid of the log. What's the inverse of taking the log of a number? Right, doing base 10. So I'm going to 10 both sides. So the 10 and the log cancel. So x squared equals 10 squared, which is 100. So x equals, or
10.
Negative 10. So that one has 2 against words, so that is nice and easy. Okay? Okay. So natural logarithm. Now, are we warm enough? No? Okay. All right, so before we can start messing around with this, well, first of all, what are you going to do with the natural log thingy? We're going to get rid of it by using what? E, okay? But I can't do that yet because I have this plus this, okay? So I need to combine them into one single thing. So how do I take the natural log of 3x minus 2 plus the natural log of x minus 1 and combine it into a single thing? Just do, what's that? No, you remember that addition when you're dealing with logs and natural logs is the same as multiplication. So I changed it into this.
oh yeah.
Okay, remember that game we played before? And then same deal over here, I want to get rid of that 2 in front of the natural log of x. How do I do that?
Can you put it on the x?
Yeah, I'm going to make that, turn that into a exponent. And now that I have a single natural log on the left and a single natural log on the right, what can I do? What? Right, so I can make it both base e, so those cancel and those cancel. So 3x minus 2 times x minus 1 equals x squared. So I still have to solve that kind of nasty equation. Right, so I have to FOIL this out. So first times first, 3x times x is 3x squared. Outside 3x times negative 1 is negative 3x. Inside, negative 2 times x is negative 2x. And last, negative 2 times negative 1 is plus 2. So you get 3x squared minus 5x plus 2 equals x squared. Now what?
Move the x squared over.
Move the x squared over, so that's going to be 2x squared
What?
minus 5x plus 2 equals 0. And then now that we have it set up like that, we can use the quadratic equation, we can factor, we can graph, all those fun things. Okay? Just trying to find the value of x.
That whole thing here, back in there, that answer.
2 and 4.
Okay, so you can factor that into 2x minus 1 times x minus 2, which means that x equals 2 and also 1/2. Or you can just plug in a equals 2, b equals negative 5, and c equals 2 in your calculator and get the same answers. Yeah. No, that's not a coincidence. That's a thing. Okay. Yes. That's the thing. Okay, one of these we have to throw out. Which one and why? 1/2. Why? I wouldn't make it 0. If I put 1/2 into here, 1/2 minus 1 is negative 1/2. And I mentioned last week you can't take the natural log of a negative number. Okay, so this one has to get tossed from the here. Okay?
Did I say 0? I'm not less than 0.
Yeah, I figured you did. Sorry. No, and then there's one more way that you can do these. Okay, one more method that you can use to solve these types of equations, which will always work. Yeah, you can graph it. Okay? So if I have something wacky like e to the x minus e to the negative x divided by 2 equals 5, you might say to yourself, okay, what's something easy that you can do to simplify it right off the bat? What? Yeah, I can multiply both sides by 2. So I can go e to the x minus e to the negative x equals 10. And then you can say, well, I know if I had a single e thing, I could take the natural log of both sides. But I don't have a single e thing, and I've got a negative exponent, and I'm not really sure where to go from there. So just don't worry about all that stuff. Just graph it.
How do I do an e? Oh, okay.
So on one side, I'm going to graph e.
Wait, why does it not cancel us? E to the x minus e to the negative.
Because e to the x and e to the minus e to the negative x are not the same thing. So why would they cancel?
No, because aren't there?
No, it's 1 minus negative 1. Because 1 is e to the x and 1 is e to the negative x.
Okay, then how do you
Okay.
know what x?
So on one side, I'm going to put in e to the x minus e to the negative x.
Oh, okay.
And then on another equation, I'm going to put in 10. And then what I'm going to do is I'm going to look to see where those two graphs cross. Okay? Now, yeah, so this is my intersection point up here.
So just find.
Taylor's guessing 2. We don't want to
No,
guess.
it's like 3.
So we're going to go second count 5, which is the intersection thing. Hit enter 3 times, and you get about 2.31-ish.
Just hit enter 3 times.
Yeah, the intersect thing is weird. It goes, the first question it asks you is, because you can have more than 2 graphs at the same time, so the first question it says is this the first curve? Is this the first one that you want? So you say, enter yes. And then it's saying, is this the second curve? Is that the one you want? And say, enter yes. And then it says, give me a guess where they cross. But you can just start anywhere since there's only 2 of them, so you just hit enter again. And then there you go. Okay? Okay, so what we have learned today, hopefully, is 3 different ways to solve these things. Okay? The first thing we did is we took the log of both sides. What was your clue in this equation that you needed to do that?
The x
Right, the variable was in the exponent. So if your variable is in the exponent, then that's a clue that you need to take the log or the natural log of both sides so you can use this property to get that exponent down, okay? Then we did a problem like this where we had to go base 10 of both sides. What was your clue to do the base 10? That the fact that it was a log, okay? So if you're trying to get rid of a log, then you need to do base 10 for that. Then this one over here, we did base E. What was our clue for that? Natural log. And remember, this had a little trick before we did it. We had to combine the things on both sides. So it was the natural log of something equals the natural log of something before we could do it. And then this last one right here, since we didn't really have a good way to solve this algebraically, you can do it algebraically, but it's tricky. We just went ahead and looked at the graph. Just kind of fun doing that. Okay? Okay. Assignment.
You walk the opposite way.
You got lost in Montana?
Yeah.
I didn't know where I wanted.
Where were you?
No.